Today we're going to learn our last method for solving linear systems of equations. This one is called elimination. I like this one when the variables are both on the same side of the equation. So when it's set up like this, where you can see both the x and the y on the left-hand side, or conversely, if they're both on the right-hand side, it would work as well. Then I like to use elimination. Now, the method of elimination uses addition on both sides of the equation to create a new equation that ends up being very convenient if done correctly. So I'm going to add the left-hand side of the equation, and I'm going to also add the right-hand side of the equation to create a new one down here. When we add the left-hand side, we have to be very careful that we get our like terms together the way that they should be. So we have a positive 4x and a negative 4x. Positive 4x plus a negative 4x ends up giving us 0. We have a negative 9y plus a negative 3y gives us negative 12y. And then over on the right-hand side, a negative 21 plus a 9 gives us negative 12. So when we simplify this, we have 0 minus 12y, that's just negative 12y. And on the right-hand side, we have negative 12, and you can see that the x's have eliminated each other. That's why we call this method elimination, is because now we're left with just one variable, and we can solve this easily by dividing by negative 12. All right, that gives us y equals positive 1. We have the value for one of these variables. We're going to go back to our original equations and plug that in to find the other one. So we're using substitution like we did in our last lesson. All right, so I'm going to take this y value, I'm going to put it up here in place of y. It doesn't matter which one of these you choose, just pick whichever one looks easier for you. So if I put the value in there, I get 4x minus 9 times 1 equals negative 21. Let's solve this. We get 4x minus 9 equals negative 21. Add 9. We get 4x equals negative 12. Divide by 4, and we end up with x equals negative 3. So we have both of our values, negative 3 and positive 1. And we're finished with this. Now I want to pause for a second and talk a little bit about why this works and how we can get it to work, because it's not always going to work so nicely with this. On our second set of equations, we will notice that negative 6x and 5x, if I were to add those together, do not eliminate each other. That ends up being negative 1x. However, these y's are positive and negative, and they're the same value for their coefficient. It's a 1. So we have a negative 1y and a positive 1y. Those two are going to eliminate each other. We can see back here that we had a positive 4x and a negative 4x. So positive and negative, and then both of them were 4. And so when we have them match up like that, it's going to eliminate the variable. That's convenient. Let me give myself some more space on this one. So when we add those together, negative 6x plus a positive 5x gives me negative 1x. Negative 1y plus a positive 1y is going to end up being 0, so that eliminates. Again, those match up, negative and positive, and the same value. Over on the right-hand side, we have a positive 10 plus a negative 10. We get 0. Now, I didn't write this 0 because I don't need it, because we have this on the other side. I do need this 0 because it's the only thing left on that side, so make sure that you write that down. Finish this out by dividing by negative 1, and we get x equals 0 divided by any number is still 0. Okay, we're going to plug that back in here. I'm going to choose this second equation right here, and let me clean it up so it looks nicer. Because it's a positive value, I like picking that. It won't really matter much with the 0, but if this was another number, that would be nice. Okay, so I'm going to put this 0 in for the x right there. That gives me 5 times 0 plus y equals negative 10. 5 times 0 is 0, so we end up with just y equals negative 10, and we're done. It's nice that the y has a positive value as well. So we have 0 and negative 10 is the solution to this one. One more example for this, and then we'll get to some more complicated ones in the next video. Right here, you'll notice that none of these variables match up with their coefficients. There's an 8 and a 4, which aren't the same. There's a negative 5 and a negative 3, which aren't the same. So we've got to adjust this one. And I'm going to pick the x's because 8 and 4 are easy to manipulate together. Now, we've changed equations in a lot of ways when we were solving equations, and I normally wouldn't do this, but I sure would like to get these to match up And so I'm going to choose to multiply this by 2 so that both of these are going to be 8. Now that would give me a positive 8, and I need a positive and a negative like we had here, a positive and a negative. So I'm going to choose to make this 2 a negative 2, and that will give me an 8x, a negative 8x, to match up with this positive 8x so we can eliminate those. Okay, now I have to do this properly though. I can't just multiply this value by negative 2. If I'm going to work with an equation, whatever I do to one side, I need to do to the other side, and I need to make sure I multiply all of these terms by the same thing on both sides so that we can keep both sides of this equation equal. Okay, let's follow through with that. Negative 3y times negative 2 is positive 6y. 5 times negative 2 is negative 10. And now you'll notice that we have a new equation where this matches up with that. So these are going to eliminate each other. Okay, I'm going to rewrite this equation and line it up with this. I'm not changing anything right now. I'm just organizing so that this equation lines up nicely here. Okay, we are now ready. We have a negative 8x and a positive 8x. If I add those together, then they become 0. Let's add these. 6y plus a negative 5y gives me 1y, or just y. And a negative 10 plus 11 is positive 1. So we have our y value as 1. Let's go back to our equation here and plug it in. I'm going to pick this one because I like the smaller values. So that gives me 4x minus 3 times my y value, which I know is 1, equals 5. Solving this, we get 4x minus 3 equals 5. Let's add 3 to both sides. We get 4x equals 8, and then we'll divide by 4 to finish it out, so we get x equals 2. So our solution, we have both our values is 2 and 1. And we're finished with this one. So again, one more time, just make sure that you have some values that match up. And if they don't match up right away, we can multiply both sides by a chosen value so that they do get to match up. We chose a negative 2 because that gave us a positive and a negative 8x. So base your decision on that. Whichever is easiest, you can change the y's. We'll see some more in the next video. Thank you.